Hey folks, welcome back. Today we'll be talking about a new device called as ASA, Adaptive Security Appliance, right? So as you see on my screen, I have a GNS3 with a very simple topology. I have the Cisco ASA, present here at the center over here, and then I also have my routers R1, R2, and R3, right? So you can assume this to be a typical configuration of in an organization wherein you have like the internal or the inside of the organization, which is probably the router R1, right? So this is like the inside of the organization, and this is the DMZ zone, right, of the organization, where you have like the web servers and all of that, which has to be accessed from the internet, and R2 basically represents the outside world or the outside internet, right? And the firewall is basically present over here to prevent or to control the traffic, right? um, yeah, so that's the plot which we have here. Now as you go ahead, what we'll look at is we'll look into something called as the interface configuration. We'll look at security levels, we'll look at access policies, and then remote management. Sweet. Okay, so by default your ASA firewall is a layer 3 device with like full routing capabilities. Unlike a router, the firewall does not allow all the traffic to traverse through it, right? So it will not allow all the traffic. So traffic flow through the firewall is controlled by security levels of the interfaces. Traffic from a high security level is allowed to flow to a low security level, right, by default. So let me start configuring and explaining to you what that actually means, right? So this is my firewall, this is how it looks. Let me start. So we have three interfaces: 0/0, 0/1, and 0/2. Let me start by configuring 0/0, right? So what does it mean? So let me go down to the config mode. Sorry, let's go to enable and let's go to conf t, right? Wait, let me just clear my screen a bit. Great. Now if you look at this diagram, you can see that I have mentioned something called as inside, outside, and DMZ, right? So in case of ASA, every single interface need to have four important parameters, right? What are those four important parameters? Let me show you. So it's going to be show run interface. Probably let me pick this 0/0, right? So if you look at a particular interface 0/0, there are four things. One is your shutdown and no shutdown of the interface. You need to have a name for the interface. Then you need to have a security level and the IP address configured on it, right? These are the four important parameters for any interface. Now I think we probably know about IP address and shutdown from the router's point of view, but then these are a couple of new things. So nameif is basically the name of the interface, and if you name the interface as inside, it is given a default security level value of 100, right? So that is the thumb rule. So you give a name of inside, then this gets a interface, or this gets a, the security value is 100. Let's try that out, right? Let's try that out. So we have the interface 0/1 over here, which is my inside of the organization. So I need to have a higher security level. So let me configure that. So you can see 0/1, the nameif is inside. I put in a IP address, and I also have a no shut. Done. So now if I go back and if I look at my configuration, let's see 0/1, you can see that just because I put in the interface name as inside, I have got a security level of 100 by assigned to it by default, and I also have my IP address assigned, right? So these are the, okay, I think I forgot, okay, it's also no shut, right? So yeah, all the four parameters are up there. So similarly, let me quickly configure the other two interfaces as well. One is my interface towards 0/0, which is towards the internet. I'm going to name it as outside. So as soon as you name it as outside or any other name, it gets a security value of 0, right? And I will tell you why, the significance of that after configuring the DMZ part as well, right? So as you see here, I'm basically configuring a security value explicitly of 50, right? Because the name of the interface is not inside, by default it gets a security value of 0, so I'm just modifying it and putting it as 50. I think that should be good. Sweet. So now that we have done that, the idea behind this, why have I done this? So whenever I configure an interfaces inside, it gets a higher security value, which is 100, and anything other than inside, it gets value of 0, right? So in case of my outside interface, the security value is 0, and in case of DMZ zone, my security value is 50, right? Now the basic thumb rule in case of ASA firewall is that the traffic by default flows from higher security value towards lower security value. So we will have, or we can have, or the traffic is allowed in this direction, right, from R1 to R2 in this direction, right, because this is having higher security value. Similarly, the DMZ zone has a security value of 50, and so the traffic is allowed like this as well, from DMZ to R2. But at the same time, you can't have traffic flowing in from R2 towards R1, because this is of lower security, this is of higher security, right? Yes, there is an exception, you can play around with it using the ACLs, but by default this is not allowed. R2 is not, I mean, you can't have a traffic going in from R2 to R1. Similar is the case from R2 to R3, right, because of the security levels. So this is how you basically configure, you know, the interfaces in case of the ASA. So we have actually configured all the three interfaces down here. Right, let me quickly go down and configure my routers as well, just some basic configuration just for the connectivity purpose. Right, on my R1 router I'm gonna put in something like this. Let's go down to config mode, probably clear my screen, I think that'll be better. Right, so I'm gonna put in a IP address on my Ethernet 0/0, which is 10.11.11.1, and I'm gonna put a default route towards my you know, gigabit Ethernet of this interface of ASA. Line VTY 0 to 4, right? I'm going to put a password. Transport input is Telnet. I'm enabling Telnet on this interface because we're going to play around with that later, right? So I've done that. So the same configuration basically goes on R2 and R3 as well. Just the IPs is going to be different, right? So let me put that as well. So on my R2, it's going to be Ethernet interface, the address, the static route, and I also have the Telnet. Done. The last one is my R3. Let's do that, which is towards my DMZ. Okay, one sec. I think probably did not get copied. Yeah, this should work. Yeah, there you go. So it's pretty much the same. So there you go. So we have configured the routers and the interfaces of my firewall as well, right? And we learned the rules for the traffic, right? How the default rules, you know, which are followed while the traffic traverses through my firewall. Sweet. Now I think if you go back when I said there is a way, right, there is a way for the traffic to flow in the reverse direction, right, from a low security level to high security level, and that can be done by using ACLs, right? So that is the use of ACLs over here, right? So we are going to try out a couple of those things now. All right, so why do you do that? Okay, give me a minute, let me pull that up. Okay, so ASA config is done, that's fine. Yeah, so traffic flows, right? So we're going to look at the ACLs and all of that. So by default, all traffic, you know, would flow from high to low, right? Only the interesting thing about ASA is that it basically inspects only the TCP and the UDP traffic, right? So what happens is if the traffic is, let's say we have you know, traffic flowing in from R1 to R2, and if the traffic is TCP UDP, then it is basically filtered by the ASA, and it creates what you call as return entries, right? It creates return entries in the state table of ASA. So that's why, you know, so when the packet basically returns from R2 towards R1, the ASA looks at the state entry and, you know, permits that particular packet to go inside, right? Because otherwise, you know, you actually, it basically has to it would be contrary to the thumb rule of ASA, where, you know, traffic has to flow from high to low, right? So let's say you have a telnet session, right? R1 is initiating a telnet session towards R2, right? So you need to now have a bidirectional, or the traffic flowing in from R1 to R2 and R2 to R1 as well, right? Now for that reason, what happens is our ASA basically inspects every single TCP and UDP packet and creates a return entry, and because the session was initiated from R1 or from inside, it will basically allow that session or the packets to come inside, right, though it is from R2 to R1. But if you do a similar ping from R1 to R2, it would not work, right, because ASA just looks at the TCP UDP packets. So we could try that. So I'm on R1 now, right now, right? Let me just end this on my R1. I have enabled telnet everywhere, so let's do this. Okay, so telnet, I need to telnet to 192.1.20.2, right? Right, that worked, right? Telnet worked, right, because we did it from R1 to R2, which is from a higher security level to a lower security level, right? Now let me show you, let me exit this. Let's see if ping works, right? Let's do the same thing with ping. Will ping work? Not. So before doing the ping, let me also turn on debugging on my R2, because we will get to see what's actually happening then, right? So let me turn on the debugging. Hope this is right. ICMP, yeah. So the debugging is turned on, and let me go on R1 and let me initiate the ping. So the ping has started, but the ping is not happening. But if I look at my R2, you can see that R2 is actually getting the packets and it is sending echo reply, right? But the echo reply is not received by my R1, and as a result of that, the ping is not successful, right? The reason being, ACID doesn't look at any other packets other than TCP UDP. So by default, it inspects TCP UDP, and my as a result, the stateful entries are not created for any other kind of packet, so the ping doesn't actually pass through. So let me go back and do the telnet again, right? So let me do a telnet from R1 towards R2, which is 192.1.20.0, sorry, 20.2, right? By default, R1 is at a higher security level, so this should pass through, and there you go, I got the terminal as well, right? I've got R2. Now if I do the same thing from R2, will it work, right? Let me telnet towards R1, which is 10.11.11.1, right? It's not working because this is at a lower security level than R1. Right, now how do we use ACLs to reverse this behavior, right? So this is the default behavior: higher security level, lower security level, it is allowed, right? But you can reverse it, or you can actually have traffic coming in from lower security level towards higher security level, but then you can punch holes through the firewall using ACLs. So that's where your ACL comes into picture, right? So what we are going to do now is we are going to enable the telnet functionality from R2 towards R1. And how we'll do that? We are going to enable that using a access list, right? So we are going to do the access list on my ASA, right? So let me clear the screen, right? So I'm on my ASA. Let me go inside the conf mode. Great. Now let's start with the access list. We're going to write a name for the access list, ABC. We're going to do a permit. We're going to do TCP. We're going to do host, right? And the IP address 192.1.20.2, right? That's because that's the IP address over here of R2. And this is a basic access list, right? We have been doing that on the routers as well. So I'm going to put the IP address of my other side, which is 10.11.11, probably .0, because for the entire network. And I'm going to put a mask here, .0, and the port is telnet, so I'm going to use telnet, right? So I have put the ACL. right? If you want to have a look at it, we can do that. Show run access list. There it goes. We have the access list defined here. Now just define the access list is not sufficient. We need to have a access group, right? So let's do that. So let's do the access group. So we're going to define access group, and let's use a name for that. You're going to use it as ABC. The direction, either it is inside or outside. So I want to do it inside because we are talking about having a telnet connection, you know, towards or inside my network, right? So inside this interface. So I'm going to put it on this interface, and so it's going to be in, and I need to define the interface. Which interface? The outside interface, right? There you go. So I can have a look at everything. Show run access, probably the group. Yeah, there you go. So we have that. So now that I have punched a hole in my whole, you know, ASA firewall principles, I'll be able to do a telnet. So can we check that? Can we do a telnet from R2 towards R1? Let's try this. There you go. We got the access now, right? So I have the R1 accessible via telnet here. It was not accessible earlier, but now it is. So by doing that, we were able to do that, right? Okay. So moving on, what do we do next, right? So one of the feature which is enabled on all the interfaces of my firewall by default is ICMP, right? And as a result of that, we were able to ping as well, right? So ICMP is enabled, whereas other services, you know, they are disabled by default, right? So how do we control this ICMP, you know, on the firewall interfaces, right? We can do that as well. So what do we do now is we are going to deny the ping function. So let's see if we can, before this, let's see if we can ping from R2 towards my, let's exit this, let's do a ping from R2 towards my ASA, which is 192.1.20.10. there you go, it works, right? That ping worked this direction, right? Because ping is you know, is a, or ICMP is something which is enabled by default on all firewall interfaces, right? So how do we, you know, prevent this, or if you don't want, you know, devices to reach you or reach your ASA via ping, we can disable it, right? How do we do that? We go and put in a command called ICMP deny any and the interface which is outside, right? Now let's go and repeat the same thing. Will this work? No, it's not, right? You can see the ping not working now, right? So we were able to do that. Now imagine you have a case where you want the ping to work from ASA towards R2, right? So will that work now with this, with the current configuration? I doubt it, right? Let's see that. So what we're trying to do is ping 192.1.20.2. no, it's not working, right? Because by using this command we have disabled the entire ICMP, right? So we will have to now enable ICMP in only one direction, and the direction is from from ASA towards my R2. So how do we do that? That's pretty simple. We will go and put this command ICMP. So let's do the config mode, my bad. ICMP, right? Let's do a permit, works, and let's do a any and echo reply, right? We need a echo reply over here because we need to allow that, and we need to allow it on the outside interface, right? There you go. So now we will be able to ping my 192.1.20.2, right? Okay, I think I should have removed the earlier configuration, my bad. I should have removed the configuration over here, right? So I didn't do that. Let me remove that. Now let's do this, and let's also see the configuration. Okay, now it should work. Let's do a ping now. There you go, it worked, right? So what we have accomplished now, we were able to prevent R2 from doing a ping towards ASA, right? But we have enabled the ping functionality from, or we have enabled ICMP from the ASA towards R2, right? And if I clear my screen, this is how it looks. So if I do a show run ICMP, right, this is the command, right? By default, you see you have this one permit and the rest is deny, right? So that's how it works. So it allows only the echo reply to go through the outside interface over here, and that's why the ping is working in this direction, right, from ASA towards my R2. So yeah, this is basically access policies is what I would say. You can do a lot of such things, um, right? So if you probably, we can go one step ahead on what you can do is, let's say from R2 we want to enable the ping but from only one IP address, right? Let's say we want to enable it from just this IP address over here towards ASA, right? So again, that also would be done using a using this ICMP, right? So ICMP permit, we can do permit, and we can do a host, right? Which host? Which is 192.1.20.2, right? And I'm gonna allow echo now, right? Because it is in this direction we want, right? So we're gonna do echo and outside, right? So by doing this, now we have enabled, or let's look at this. There you go. So we have enabled two things. We have enabled the ping from ASA towards any of this network, right? Anywhere outside, and we have also enabled ping especially from this IP address over here, right? So if I can go to R2 and I can do a ping 192.1.20.10. There you go, it works, right? So that was all about access list, right? So access lists and controlling your ICMP, right? So that's pretty interesting. So you can use access list like I showed earlier to kind of contradict the entire principle of ACLs, right? And the basic principle or the thumb rule is that traffic has to flow from high to low and not from low to high. But if you want to puncture through the ACL and then you can basically define an ACL to do it for you, right? So as a result, we were able to do it here as well. We were able to ping, or we were able to make the traffic move from a lower security level to a higher security level by using ACLs, right? Then we also looked at how do we control the ICMP behavior of the interfaces, because ICMP is something which is enabled on all the interfaces of the ASA. So we need a mechanism to control it, right? There might be networks where you would want the ping functionality on the network, or you don't want the ping functionality, so you can control it by using the ICMP commands, which I showed you just now. Now the last part probably is the remote management, right? Remote management, you can do it using Telnet and SSH, right? So probably let's try the Telnet. Telnet is not very favored because of the clear text communication. It's not recommended. It does not work on security level 0 interfaces at all, right? So it would not basically work on this outside interface, but we could try it on this inside interface, right? So how do we do that? Let's go to my ASA, right? Great, let's go here. Let's call it as Telnet, right? And the network is 10.11.11.0 to 55.255.5.0, and the interface is inside, right? That's it. This is one command, but you need to define a password for it, right? Let's define password as Cisco 123, right? That's it. So now by doing this thing, we have enabled Telnet on the inside of the network on this interface, which means I can go and do a Telnet into the device from my R1, right? So let's do that. Can I do a Telnet 10.11.11.10? right? There you go. It is asking for password, which is Cisco 123. Works. And I can also see my right, so this is working. So I can also see the session over here by using the command who, right? If I do a who and I get to know the telnet session which is running on it, right? So that's good. So that's telnet, but not very favored because it's clear text and you can do it only on inside interface, and you can't do it basically on any interface with the security level of 0, right? So SSH, let's see SSH. So it's encrypted communications, requires a RSA key, right? So let's go back to my ASA and let's generate this. So let's start with the command domain name, right? Let's call it as cisco.com. Sweet. Let's do crypto, right? Crypto key, and we're going to do generate, right? We're going to do RSA modulus and 1024. Okay, so we're going to put a yes, please. Okay, my bad. Yes. Okay, so we are generating the RSA key pair, and now we are going to define the SSH command, so which is going to be SSH 192 dot it's going to be for the 20 network, right? 192.20.0, maybe 255.255.255.0, and we're going to put it on the interface outside, right? I've enabled it on the outside interface, right? So that's good. And now you know that for SSH you need to have a username and password, right? So we're going to put username admin, and we are going to put password as Cisco 123. Okay, and just by putting username password is not sufficient. You need to do AAA as well and point it to the local database which you just now created. So let's do local authentication and SSH console, right? I'm gonna define local, so local should be in caps over here for it to work. Okay, so that works. Now the SSH should work, right? Let's see if that works. Let's go to R2. Let's see if we are able to SSH into the device, into ASA, right? So let's see SSH. The command is basically SSH minus L admin, right? Because there's a username which I defined over there. And what do I have to do next? I need to mention the IP address, which is 192.1.20.10, right? The password which I defined was Cisco 123. Let's put that, and we have the SSH working as well on the for the ASA device, right? So I think we covered a lot of things. We looked at the interface configuration. We looked at right. So we looked at the security levels of 100, 0, 50, and so on. And we talked about how the traffic has to flow from a higher to lower. But then you can also do the other way around by using ACLs, right? So that's where we looked about ACLs. We configured ACLs as well to have the traffic flow from R2 towards R1, right? And we also looked at ICMP to be specific, because ICMP is enabled by default on the ASA interfaces. So we looked at ways to control the ICMP traffic. And at last what we did was we kind of looked into the telnet and SSH, or basically the remote management of the device, right? We looked into telnet, and we did a telnet from my inside interface, and we were able to telnet into the ASA. We also did a SSH from the R2 device as well. Thanks for watching.